Hello everyone. This is Gayatri Priya, Assistant Professor in the Department of ECE of RMD Engineering College. In today's session of Electron Devices and Circuit Theory, we are going to discuss about MOSFET. Why we have to come for MOSFET or what are the limitations of JFET. So comparatively it is having a slower operation and as well as a high drain resistance, right? And moderate input impedance. These are the limitations of your JFET. Because of all these reasons, we are coming up for MOSFET. Majorly, the MOSFET is used as light intensity control, motor control, and generator applications. Because of it is utilized as a high voltage controlling device, it is showing a tremendous performance in almost all the electronic circuits. Let us get into the construction of MOSFET. Here we have taken a lightly doped p-type semiconductor as the substrate, and here we have taken two heavily doped N material and which is being diffused into this p-type substrate, right? And here we have kept an oxide which is nothing but SiO2. The other name for the MOSFET is going to be IG-FET. FET we know, field effect transistor. IG stands for insulated gate. That is, the gate terminal is being insulated from that of the substrate. That is, in between the gate and substrate, we have kept an oxide layer, or it is called as a dielectric layer or an insulator, that is an SiO2 layer is being made. Over the SiO2, metallization is made in order to make down the gate terminal, right? So we don't want any such insulation in case of the source and the drain. Therefore, the oxide layer is being etched out in this particular N plus well, and a metallic contact is made in order to keep the source and drain. The one more terminal is called bulk or body or substrate. These are the types of MOSFET devices. So generally it is categorized as enhancement mode, depletion mode. In both the category we are having N channel and P channel. Right. What might be this depletion? Depletion in the sense depleted of, that is void of. Something is missing or something is declining. Whereas coming for the enhancement mode, something is increasing. So getting into the actual definition of depletion mode, what we are coming to say, whenever no voltage is applied at the gate terminal, this mode gives a maximum conductance. So maximum conductance in the sense the current is going to be very large. Even we apply a gate terminal, a positive or a negative voltage, this conductance will be reduced. That is, the channel conductivity is reduced. So just opposite to that is the enhancement mode, where no voltage is applied at the gate terminal. Instead of maximum conductance, it will be giving maximum resistance. That is, no current will be flowing up here. And whenever a potential is applied at gate terminal, it shows a increasing conductivity. These are the symbol of MOSFET devices. Okay, this is the gate terminal, source, drain terminal. Here the substrate is being indicated by a dotted line. Okay, if the substrate is mentioned as a solid line, then that is for depletion mode. In enhancement mode, this substrate line will be broken up. If the arrow mark is pointing inside, then that is for N channel. If the arrow mark is pointing outside, then that is for P channel MOSFET. So coming to the construction of a N channel D MOSFET, here we have taken a lightly doped p-type substrate as discussed. Here we are having two heavily doped N region diffused over this p substrate, and over which you are having a dielectric layer, that is your SiO2, a metallization layer, and the gate terminal is connected. And we have removed this SiO2 layer in these two parts, and a metal is made in order to connect the source terminal and the drain terminal, right? Okay, coming to the working operation. Whenever we are applying the gate source voltage as 0, that is grounded, and applying a positive potential at VDS, so what happens in the sense, here we are having the N plus well, that is comprising of electrons. These negatively charged electron will have a tendency and get attracted by the positive polarity of the drain terminal. So the electrons present in this N well will be attracted, and obviously these electron will be getting attracted. Why? Because in the sense the source is negative, this negative and negative will get repel, and therefore it will be moving towards the positive polarity of the drain terminal, thereby creating a channel, diffusing a channel knowingly or unknowingly. This part acts as a capacitor. Why? Because in the sense, okay, so this is going to be a dielectric layer, that is an insulator. Below the insulator you are having the negatively charged electrons, whereas at the gate terminal is going to be a p type, there the charge carrier is going to be positively charged holes. According to the physical construction, what is a capacitor? Two equal and oppositely charged parallel plates separated by a dielectric medium, right? So as a result, what happens? The channel, it is comprising of negatively charged electrons, it will be in moving, okay? So maximum, depending upon the channel capacity, if it is going to accommodate 100 number of charge carrier, 100 electrons will be present. The current because of the 100 electron will be produced with respect to variation in the drain source voltage. Even the gate source voltage is zero. What happens? That is, the electrons from the source terminal will be attracted towards the positive polarity of the drain, thereby creating a conventional current of ID equal to IS equal to IDSS from the drain terminal towards the source terminal. This IDSS is the maximum, that is the saturated drain source current that a MOSFET could have, right? Coming to the case 2, we are applying a negative voltage at the gate terminal. This is going to be a p-type material. This is a p substrate. In the p substrate we are having the positively charged holes. That holes will be attracted by this negative polarity and it will be moving upwards. Upon moving, it has to cross over this channel. While approaching the channel, what happens? The electrons in the channel, the holes that is in movement, constitute get into recombination process and produces a new electron hole pair, thereby creating more number of charge particle. The charge particle will be under movement. That's why the current is produced. Even the gate source voltage is kept as negative, right? So coming to the third case, what happens whenever I'm applying a positive voltage to the gate source voltage? As I already discussed, this is a p-type material. The holes will be repelled, whereas the electrons present in this channel will be attracted towards this positive polarity. More number of electron will be passing over this channel, thereby increasing the channel width. If the channel width is increasing, obviously what happens? Number of charge carrier is increased, thereby the current will be increasing. This shows the effect of gate voltage on the N-channel D MOSFET. As discussed, this is a P material, lightly doped P substrate, and this is going to be your drain terminal, and this is your source terminal, SiO2 layer, metallic contact, gate terminal. If we apply gate potential as negative, the electrons present in the channel will be repelled, right? Similarly, the holes present in the p-type substrate will be attracted towards this negative polarity. So these two things get into recombination, thereby producing more amount of current. Okay, this is the characteristics curve of D MOSFET in both the enhancement as well as the depletion mode, right? So we have told VGS is equal to 0 volt. What happens whenever the voltage is increasing? The current will be increasing and it has reached the maximum saturated drain source current at VGS equal to 0, right? So if I decrease, that is if the negative voltage is applied to the gate terminal, that comes under depletion mode. If you apply a positive potential at gate source voltage, then that is a enhancement mode of operation, right? So the region left to this curve is called ohmic region. Why? Because in the sense only in this region the Ohm's law is accepted. We know Ohm's law is voltage directly proportional to current. Whenever there is a change in voltage, the current also varying proportionally, and that's why it is called ohmic region. So afterwards, what happened? The channel could accommodate only this much amount of charge carrier. So the movement will be the same. Therefore, the current will be same during the saturation region, right? The region well below this VGS equal to VP is called the cutoff region. What is this VP? When VGS becomes VP, right, the drain current becomes equal to 0. The voltage, the gate source voltage at which the channel is closed. If the channel is closed, no charge carrier will be moving, and hence the current is going to be 0. That is called your pinch off voltage. This is the transfer characteristics, variation of a drain current with respect to gate source voltage at constant VDS. So the cutoff region is explained, followed by the linear region or ohmic region as well as your saturation region. Right? So far we have discussed the N channel D MOSFET. Coming to the P channel D MOSFET, instead of having a lightly doped P type material, here we have taken N type material, and two heavily doped P material is being diffused over this metallic contact. Here this is SiO2. From there, through the metallic contact, the gate is made. Okay, so the same working principle. Even the gate source voltage is 0 and the drain voltage is negative. What happens? The positively charged holes present in the source will be attracted towards this negative polarity, thereby diffusing a channel. Knowingly or unknowingly, a channel is being created, right? And this condition is being explained. The same way, next we will be giving a positive voltage to the gate source voltage, and we will be seeing to the characteristics curve. The right hand side depicts the drain characteristics and the left hand side curve depicts the transfer characteristics. The region in the left side presents the depletion mode, and this is called the enhancement mode. Similarly, this is the enhancement mode followed by the depletion mode, right? And this is the impact of gate voltage on your P channel D MOSFET. Similarly, here we are having a N type material as substrate. The electron will be attracted towards this positive polarity. Because of the positive polarity, the holes, positively charged holes in the channel will be repelled from the gate, and therefore these get into recombination, thereby producing higher amount of current flow, right? So now we have discussed an N channel depletion and P channel depletion. The N channel depletion is turned on whenever the VGS is greater than or equal to 0. Similarly, P channel D MOSFET is turned on when VGS is less than or equal to 0. Similarly, for your N channel and P channel enhancement, the condition would differ. That is quite opposite to this, right? So based upon this summary, we can utilize the MOSFET as a switch. And these are the very few advantages of your MOSFET. It is smaller in size, occupies less space, tremendously high input impedance, and therefore the operating frequency is high, good reliability, lesser noise, no saturation current, reverse saturation current. Since the MOSFET is a unipolar device, it consumes only lesser power. Hope you understand this session. Thank you.